Hello to everybody. In this moment I am going to explain you the heat transfer subject. Well, let's go. The objectives for this work are explain the basic concepts of heat transfer, explain the modes of heat transfer, and apply the three different laws in each mode. Basic concepts. Heat is the energy transit as a result of the temperature difference. Heat transfer is that science which seeks to predict the energy transfer that may take place between material bodies as a result of temperature difference. Thermodynamics is the state science of energy, the transformation of energy and the change in the state of matter. Heat flux, heat transfer flow in the direction per unit area. Modes of heat transfer. A conduction heat transfer. Conduction may be viewed as a transfer of energy from the more energetic to the less energetic particles of a substance. A temperature gradient within a homogeneous substance results in an energy transfer rate within the medium, which can be calculated by Fourier laws. In these laws, differential of time on differential of positions is the temperature gradient. In this case, Q is a rate of the heat transfer in watts, K the thermal conductivity, and I the surface area perpendicular to the direction of heat transfer. In the different states, for example in gas, the collision molecular and the diffusion molecular is more than in the liquid. In the liquid is less. The collisions and the diffusion. But in solid, the lattice vibrations and the flow of free electrons. In this case, you can see the table of thermal conductivity, the different values of K. A convection heat transfer. Whenever a solid body is exposed to a moving fluid having a temperature difference from that of the body, energy is carried off convex from or to the body by the fluid if the upstream temperature of the fluid is T and the surface temperature of the solid is Ts. The heat transfer per unit time is given by Newton's law of cooling. In this case, H, the convection heat transfer coefficients of the fluid, A, the convection surface area, T, the wall surface temperature, and T infinity, the bulk fluid temperature in Kelvin. A radiation heat transfer. The third mode of the heat transmission is due to the electromagnetic wave propagation, which can occur in a total vacuum as well as in a medium. Experimental evidence indicates that radiant heat transfer is proportional to the fourth power of the absolute temperature, whereas conduction and convection are proportional to a linear temperature difference. The fundamental Stefan Boltzmann's law is this. In this case, E is emissivity range 0 to 1, then Boltzmann's constant, A the body surface area, and T the absolute temperature. Well, thank you for your attention.